Do you know that the WHO issued the number of obese people about 40% of the global population? In Taiwan, most people work long hours and are under pressure to adopt unhealthy living and eating habits. If you eat out frequently, it's also hard to reduce fat uptake in the diet, and these are the causes of obesity, as well as many chronic diseases. For effective weight control, the use of legal anti-obesity drugs are one of the choice. These drugs are helpful for user to maintain a healthy weight. Orlistat is the main active ingredient in over 75% anti-obesity drugs on the market. What is orlistat? Orlistat is a lipase inhibitor. When it binds to lipase, it reduces the degradation and absorption of gastrointestinal fats. This is how it helps people controlling weight. However, the use of anti-obesity drugs that reduce fat absorption and excrete the excess fat from large intestine produce some unpleasant side effects, such as diarrhea and oily stool. The side effects happen to approximately 79% of those who take the drug. It's necessary to decrease the dose to minimize or eliminate the side effects. But this has led to much lower effectiveness of the drugs and increased the time spent on maintaining weight. And it also directly impacts the overall sales performance. In order to solve these problems, the team from the National Health Research Institute, NHRI, Institute of Biomedical Engineering, and Nanomedicine spent years to investigate a nanomaterial with the suitable structure named mesoporous silica nanoparticles, MSNs. The side effects of these drugs were reduced by using MSNs. The formulation of silicon dioxide is a biocompatible material that is commonly used in food additives. It has also been used as a component of gastric medicine, is quite suitable for oral administration. MSNs can absorb oil and create of gelatinization efficiently. When people swallow the food and the medicine containing orlistat and MSNs, they first pass through the esophagus and the stomach, then entering the duodenum. This is where the chemical reaction takes place. The lipase digests oil into smaller molecules. However, when it binds to orlistat, orlistat blocks the lipase function. In the meantime, the MSNs move toward the fat. The MSNs then cover the oil droplets and cause the molecules to rearrange their structure, forming gelatinization. Finally, the gelatinized oil will be excreted from the body in the feces. In sum, the nanomaterials can absorb and gelatinize the non-degraded oil, hence reduce the side effects of the anti-obesity drug. And it also improves the quality of life for those who use orlistat. Furthermore, MSNs is attractive as a material for combination therapy with orlistat. We developed MSNs to reduce the side effects of lipase inhibitor-based anti-obesity drugs, thereby enhancing the utility and market development of these drugs, and establishes a new application model for MSNs.